everyone, it's Miss Fred. I'm here to teach you about properties of exponents using the multiplication and division operations. I have a couple reminders for you before we jump into those problems. Okay, the first one I want to talk about is the variable x and the invisible properties that it contains, even though we don't see anything here except for just the variable. So if you see a variable and there's no exponent, it is assumed that the exponent is 1. So in the beginning of these problems, put an exponent of 1 right away so you don't miss the 1 when you go to add the exponents together. The other thing I want to point out to you, just to remind you, is that there is a coefficient in the front, or the number in front of the x is 1 if it's not written there. So again, invisible 1 here, invisible 1 here. The next thing I want to talk to you about is reducing fractions. And this is the famous problem that we have issues with when we reduce. So if you see something like this, sometimes we get super excited, we see the number 2 is the answer, and we move on without really thinking about what we're looking at. The number in the top, which is the numerator, is smaller than the number in the bottom. So if this is the case, if the number on the top is smaller, this fraction is smaller than 1. So there's no way the answer could be 2. So you need to train yourself to look for a common number that divides into both the numerator and denominator. In this case, it's 3. So I'm going to divide by 3 on the top and bottom. And just to remind you, the reason I can do that is because this right here, 3 divided by 3, is equivalent to 1. So we're allowed to do it as long as we divide on the top and on the bottom. So now when we go through the computation, it's 3 divided by 3, which is just 1, and 6 divided by 3 is 2. So we know that 1/2 is smaller than 1. This is the correct answer. So be watching out for this. This can really mess you up. The other thing I want to just point out to you is sometimes you'll get the fractions where they aren't able to reduce. So you just leave the fraction the way it is. So in other words, just kind of recopy them in the problem. Okay, we're going to jump into those problems now, so get ready. So this is what the majority of your problems are going to look like. So right here, I'm going to start off that idea again about putting that invisible 1 right away in the problem. We don't need it on the coefficient right now. We want to focus on those variables. So most of you have had this before in your other classes, but just to remind you, the coefficient in the front is 2 times 1. So 2 times 1, I'm just going to write it out here a couple times for the problems. So that's 2 times 1. And then when you're multiplying by the exact same base, the base has to be exactly the same. We're going to add the exponents together. And you can see right now that if I had not put the invisible 1 right here, I might have just put 2, and that is incorrect. Finally, I'm going to simplify what I have. So 2 times 1 is 2, and x to the 3rd power is our finished answer. Okay, let's move on to number 2. Okay, number 2, we're going to put that invisible 1 right away. So 6 times 2, the base is exactly the same, which is what we want, and it's 1 plus 2. Clean that up. 6 times 2 is 12, and then n to the 3rd power. Okay, you're probably getting the hang of it. It's probably feeling pretty easy. I'm still going to go through 4 more examples just to make sure everybody understands it. Okay, I'm going to start writing less notation for you. So look, I don't have to put in any invisible 1s because I've got exponents written already there. So 2 times 5 is 10, and then x squared plus x to the 3rd. Remember, the bases have to be exactly the same. We're going to add those together. So it's x to the 5th. Okay, you're probably seeing the patterns and the operations and how this works. Okay, got to put that invisible 1 right away. Okay, this looks a little confusing because you have the coefficient for p in the back in the front here, but it looks maybe a little confusing. So don't forget, there's also 1 in the front. So this one I'm going to write out is 1 times 2, and then p to the 1st power plus, ooh, we got another 1, and I didn't write it right away. And then clean it up. So 1 times 2 is 2, and p to the second. So that might be a little bit more difficult just because the notation might be a little bit more difficult. Okay, next problem. Okay, 2 times 5 is 10. Okay, make sure you're multiplying. And then it's a to the third plus 2, because again, we're adding the exponents when we're taking the product or multiplying these two expressions. Remember, the base is exactly the same. Okay, 10, a to the fifth. All right, so I think you have the hang of it at this point. So this is 4 times 6, which is 24. And then k to the 1 plus 3. So 1 plus 3 is 4. Okay, do the rest of the problems now in the form.